section 7.5, different ways to express probability. Now, when we're talking about probability, it's kind of like saying what are the chances of getting something to happen. For example, you think of the number of favorable outcomes that you're looking for, like a head or a tail for a coin. So if you got a coin here, you got a couple of different choices. You got a choice to either get a head or you got a choice to get a tail. Okay? So what is your chance of getting a head? Well, you got one chance out of two, because there's two possible outcomes. So the probability of getting a head is 1 out of 2. If we're talking about a die, we'd have 6 sides to it. So we'll look at it like this, and here's my ugly looking one. All right, not a very good one. I could probably come out with a better one here. Let me see. And I'll just stick one out there on the screen. There we go. So if we take one of these, there are 6 sides to this. So there are actual 6 possible outcomes. There's a 1, 2, 3, 4, 5, or 6. What are my chances of getting a 1? It's 1 out of 6. What are my chances of getting a 2? It's 2 out of 6. What are my chances of getting an even number, like 2, 4, or 6? Well, there's 3 possible chances. We got the 2, the 4, and the 6. So there's 3 possible favorable outcomes that I'm looking for over the total number of outcomes. One more skill you need to know in this unit is how to change a fraction, say something like 1/2, into an equivalent fraction that'll be out of 100 or out of 10 or something like that. When you're changing it to out of 100, an equivalent fraction, you got to look at, okay, what do I need to multiply this by to get 100? And the answer is 2 times 50 will give me 100. So if I do it to the bottom, I must do it to the top to make sure it stays equivalent. So I must times this by 50 as well. So 50 times 1 is 50. So the answer is, if you want to change 1/2 to 50 out of 100, you'd have to multiply it by 50 on top and 50 on the bottom. Some of them aren't quite so easy to change to out of 100. For example, you might have 4 out of, let me see, 6. And of course, there's nothing that you could times 6 by to give you 100, and there's nothing, so you can't really change that to out of 100. But you certainly can go 4 divided by 6 on your calculator. And if you do that on your calculator, oops, let me see, there's a calculator. And if you go 4 divided by 6 on your calculator, you're going to have 0.6666. So I'm going to say 0.66. So it's 0.60, and I'm going to say 7 because I rounded off to the nearest hundredth. And remember what these numbers mean. This is in the tenths place, and this 7 is in the hundredths place. So that is really 67 hundredths, or as we write it, 67 hundredths. So that would be changing it using division, okay? And you could use a calculator, I guess, for that part to make it easier. So if you can't change the bottom number into something out of 100 so that you can write it out of 100, then you might have to use division or a calculator to do it. Why do we need to change it to out of 100? Because remember what percent actually means. Percent simply means out of 100. So if you have 67%, it's 67 out of 100. So you should be able to switch from percent to a fraction and then to a decimal pretty easily now. As long as it's out of 100, you can change it between these pretty quickly. So you're going to need to know that for this unit. So let's look at this one. It says the lost and found box in the school office holds 7 red gloves, 8 red mittens, 9 black gloves, 5 gray gloves, and 6 gray mittens. You pick one item without looking. Okay, that's fine. Find the probability of choosing a red glove. So, which ones are gloves? A red glove would be right here. So what's our probability, remember, equals the number of favorable outcomes, or what we're looking for, over the total possible outcomes. So the probability will equal 7 red gloves, so there's 7, over the total number of gloves. Well, if we add up, 7 and 8 is 15, plus another 5 is 20, so there's 29, plus 6 more is 35. So our probability of choosing it is 7 out of 35. You could change that to a percent simply by dividing the top and the bottom by 7, because 7 will go into 7, and 7 also goes into 35. So 7 goes into 7 once, and 7 goes into 35 5 times. Now it's pretty easy to make this one on bottom out of 100, because 5 times 20 is 100. So we times each side by 20, and the chances of getting a red glove is 20 out of 100, which of course equals 20% chance. So that one's pretty straightforward. You just got to simply find out what the total number of favorable outcomes is versus your total number of outcomes that you could actually have. When you get into the next one, and the next one is going to ask you, okay, there we go. Next one's going to ask any glove. So we'll erase all this again. So let's look at the total number of favorable outcomes. So any glove. Well, there's 9 black ones, and there's 5 gray ones. In other words, there's 14 gloves. 14 of them. So our favorable or possible outcomes will have 14 chances out of, remember how many it was in total? 35 total items of clothing there. So 14 out of 35, and of course you can divide the top and the bottom by 7 to reduce your fraction. So divide it by 7. Oopsie daisy, 7. And divide this one by 7. 14 divided by 7 is 2. 35 divided by 7 is 5. So now we've got 2 out of 5, and we change that, if we'd like, to a fraction out of 100, times it by 20 again, because we want the bottom number to be out of 100. So when we times this by 20, and we times this by 20, we'll have 40 out of 100, which is 40%. We could also write it as a decimal, 0.40, just like that. And that's how we would write it. You could write it as several other things, like a ratio as well. So you might have a 2 in 5 chance of winning. When you look at a black glove, you'd simply add up the number of black gloves, which is 9. So that'll be 9 out of 35, and then you would change that just the same way we changed this one into something out of 100, if you can. And then a gray mitten, it would be 6 out of 35. Okay, looking at number 2. We're looking to describe some sort of an event where you would end up with 1/3, or 1 out of 3, for our chances. So there's lots and lots and lots of different answers. You could be like 1 hit out of 3 tries at baseball. There's lots and lots of different possible answers, as long as you can come up with some experiment for which an event occurs with each probability. Then you need a one with 1 out of 6. Maybe you can have a die. So just like we had before, what's the chances of getting a 6? It would be 1 out of 6. What's the chance of getting 100%? Well, you could have, let me see, 5 red balls. And you could say, what's the chance of drawing a ball out of the bag if you put your hand in? Well, obviously it's going to be 5 out of 5, because they're all red. So you'd have to pick something that the chance is certain, or it has to happen. And then the final one, 3 out of 8. you could pick then one that actually might happen 3 out of 8 times. And again, there's lots and lots of possible choices for that one. Okay, moving on to the spinner ones. They're very popular. It says a spinner has 9 equal sections. So, for the sake of time, I'm not going to make them perfectly equal, but you should get the point about how big they are. So if I were to make 9 equal sections, I'll just keep splitting them up. That's 4. Let's see, 1, 2, 3, 4, 5, 6. Now I've got 4. So there should be 9 equal sections, so I'm going to need one more. Now, let's pretend they're all equal for a moment. You don't even really need to draw this, but I'm just doing it for the sake of doing it. 3 sections are purple. So 1, 2, 3 are purple. 1 is black. Okay. Then you have 2 sections that are yellow. So it'll be 1, 2 sections that are yellow. And finally, 3 sections that are red. 1, 2, 3. So we have a total of 9 possible outcomes. That's our favorable outcomes. That's how many how many possible outcomes there are. Of course, for black, we have a 1 in 9 chance. For yellow, we have a 2 in 9 chance. For red, we have a 3 in 9 chance. Okay, so we have 1, 2, 3, 4. We need one more section I'm missing, the purple. The purple, we also have a 3 in 9 chance. So here's the question. It says, write each probability 3 ways. So what's the chance that the pointer lands on purple? Well, the way we know how to write it would be 3 out of 9. We could write that as a lovely looking ratio. And of course, we could write that as a percent. Now, remember how to get the percent when you're doing that one. To get the percent, you're going to end up having to divide it and change it to a decimal. And when you change it to a decimal, you'll end up with, let's see if we can do it, 3 divided by 9. Where's my calculator? So 3 divided by 9 will give me 0.33, repeating. So it will give me 0.33 or 33% chance. Okay. So that's actually 4 ways to write that probability. Looking at the next one, the pointer lands on black or yellow. So we got 2 possible things it could land on. Remember, our total number of outcomes is 9. So black or yellow means there are 1 black and 2 yellows. So again, it will be 3 out of 9. So it'll be exactly the same as number or letter A. C says the pointer does not land on red, so everything except red. So if I count the ones that are not red, I will have 6 out of 9 are red. Of course, changing that to a, there we go, changing that to a ratio will be 6 out of 9, and of course changing it to see if I can get that calculator again. There we go. Changing it to a decimal, 6 divided by 9 is 0.6666, which of course rounds off to 0.67. And that as a percent would be 67% chance. So again, you have to look at the total number of outcomes and the total number of favorable outcomes of what you're trying to get or land on. 500 raffle tickets were sold. So again, they told us right away what our total possible outcomes are. There are 500 chances to win. One ticket wins the prize, so they're telling you there's only one draw. Write each probability as many ways as you can. So Kendall in A purchased 8 tickets. So what's the probability that Kendall will win the prize? Well, if Kendall is 8 chances out of 500, if I were to change that to a, oops, if I were to change that to a, a fraction that's out of 1,000, I could do it like this. It could be times it by 2, and I could times it by 2, and I could change that to 16 out of 1,000, and we can write thousandths to the nearest decimal, but I'm not going to do that for this one yet. So 8 out of 500, I could write that kind of like this. So he's got an 8 in 500 chance as a ratio. Okay. If I want to change that to a lovely looking decimal, so 8 divided by 500 will give me 0.016 as a 6 as a decimal. Change that decimal to a percent. You just shift the decimal 2 places or divide it by, times it by 100, and you end up with 1.6%. And that is your chance. So he doesn't have a very big chance of winning. When you're looking at Lena purchasing 10 tickets, it's going to be 10 out of 500. And that one won't be too bad to solve either. So 10 out of 500 would be 10 ... 500. Would be also 1 in 50 if you wanted to reduce it to the nearest or the lowest common, I guess, the lowest ratio that you can make out of it. When you look at the third one, Anthony purchased 25 tickets. This time they're saying, what is the probability that Anthony will not win the prize? So there's 2 possible ways to do a one like that. You could figure out what the chances are of not winning. Well, if Anthony's got 25 tickets, that means there's 475 out of 500 chances that he won't win. Or if you want to look at it, Anthony's got a 25 in 500 chance. So you could calculate the chance of Anthony winning the prize and then just saying if that's the chance he's winning, the chance he doesn't win is whatever's left. For example, if this ends up being like 10% chance or 2% chance, if it's 2% chance, that means there's 98% chance he doesn't win. So I like calculating the chance he will not win the prize so that there's less steps. So again, all you would have to do is change this to a ratio of 475 to 500. But before you do that, you can always divide this by something that you know the top and the bottom will divide by, and that would be 5. So I like reducing my top, my numerator, and my denominator by whatever I can reduce it by first, and it makes the number smaller in the end. So when you calculate that, then all you have to do is change it again into a decimal and then a percent, the same way you did the first 2.